record that. Okay, so we're recording. So we're going over homework number 10, the free response questions. So dot plot gives the sale prices for 40 houses in Ames, Iowa, sold during a recent month. The mean sale price was that much with a standard deviation of that much. Okay, and find a percentile of the house indicated in red on the dot plot. Okay. Well, I suspect the way this looks right now, that's probably 200, 210, 220, 230, 240, 250. I'd probably say that the one in red is $230,000. Now, what you're going to need to do is calculate your z-score. The z-score is going to be your data point minus your mean over sigma. Remember, this is your mean. This is your standard deviation. And that right there is your data point, which is going to be $230,000. So let's go and calculate the z-score first. So I'll just give you guys just about 30 seconds or so. Go ahead and record it. And if someone could share what they get, that'd be awesome. So again, your mean you right now is, that's your mean. That's your standard deviation. You're storing all those numbers into this formula down below. Tell me what you get for Z, and then I'll tell you what we'll do next.
Mr. Amashi, what's the last number of the mean?
Oh, let me erase that. There we go. I'm getting my calculator too. Let me grab that. Okay. So again, we're doing 230,000 minus 203,388 divided by 7,600. Okay, does someone have a z-score they'd like to share? Or you put in the chat too. Remember, chat's private, so if you're afraid of getting it wrong, don't worry, I won't call you out. That z-score is not quite correct, so be careful there. Remember, the z-score should be a pretty low number. It should be less than 1 here. If you got something less than 1, that means you did it right. Okay, so someone shared 0.3037. Thank you very much for sharing that. So the z-score is going to be 0.3037. All you're doing is doing 230,000 minus 203,388. For the first person who shared the answer, make sure you put parentheses around these two. You may have not have done that. That's probably why you might have got it wrong, is my guess. So when you're typing in the calculator, if you're doing all in one line, make sure you put parentheses around the first 2 terms. Otherwise, it's going to divide these 2 together first and then subtract afterwards. That's probably what happened. So just be careful. So the z-score is going to be 0.304. We'll just round to 3 decimal places. Okay. Now, what does that mean? Why did I do that? Well, here's what we're going to do. You can go about this a few ways. You can pull up something called a z-table, which I did share with you guys. Let me pull it down. Sorry, I have my tax forms. Taxes are due tomorrow for extension, so sorry about that. Grown-up things you have to do, always fun, right? Anyway, but unlike our president, okay, I'll stop there. I'm being recorded. I won't get political, sorry. But I do pay more than he did. I will say that. So anyway, let's keep moving here. Where are we? So I've run class. Yikes. There we go, z-score. I believe I put this in school, oh, yikes, you're not supposed to, goodness. Yeah, I'm gonna have to edit some of this stuff here. Oh, goodness. All right, let's do this one more time. So you gotta be careful. I'm probably gonna wind up editing part of this video. So anyway, let me pull this up again. So z-score 0.304. So 0.304, this is 0.01. This is, let me get a spotlight out. Here's 0.3. This is actually this is 0.300, 0.3, 1, 0.32, 0.33, 0.34. So it'll be about 0.6331. So that's 63.31 percentile. So the percentile will be because what the Z table does, it tells you what percentage is to the left of where you're located. And remember, z-score 0.303 means that you're 0.3 standard deviations above the mean. So if this was the mean right here, this is mu plus 1 standard deviation. So then when the z-score is 0.303, you're going to be somewhere in the middle there. Remember, a z-score of 1 will be precisely this, the mean plus 1 standard deviation above the mean. So that kind of makes sense. That would be 63.31 percentile. Now, a more precise way you could do this is do this in the calculator. So you could do, remember, second vars, option 2. And since you already know the z-score, oh, that's for calculus. Second vars, option 2. So you could do like 0. Actually, no, darn, let's keep that 1, e negative 99. I'll do 0.304. And you keep those at 0, 1 because you're doing the z-score. It's not what I wanted. Hold on a second. That's weird. Oh, it's -1. My bad. Let's try it one more time. No wonder it was bugging out. Okay. Yeah, because you're going to the far left and you do a lower of -1 E99. Like you're doing like several standard deviations below the mean. So just, there we go. And that's kind of what, we got something kind of close to that. So that's your percentile. But still seems a little off. So let me try it one more time. Maybe I need to be a little more accurate. Let me do 0.03758. Okay, so maybe the table's a little off. So be it. That table I shared with you guys. So that's the percentile then. So we just go with the calculator. It's gonna be a better way to do it. Okay. Let's keep moving here. And again, if you don't have a calculator, you can always do this. Let me go to Google Drive. Actually, let me open all these untitled ones. So equals norm dist 0.303758 was my z-score, comma 0, comma 1. I think we did comma 0 after that. So I would say comma 1 if you want to be to the left. So you could do that too. Okay, that was that one. Now for part B, let me have you guys try part B. Calculate and interpret the standardized z-score for the house indicated by the red dot which sold. Okay, I already did that for you guys. I already interpreted. So basically you would say that about 61% sell for less represented by the red dot. So that's how you want to say it, or how you can interpret your results, you know. So that's that one. So we found percentile again. We found the z-score. So we actually did the z-score first and percentile afterwards. Okay. So now let's move down. Oh, one other thing we have to do too. You do actually want to count where it ranks also. That's actually what we should have done. So come to think of it, for part A, actually it was going to be the rank. But B is actually right here, and that's the z-score. You know, we got a z of 0.3037. We did the normal CDF thing in the calculator, or we could do normal distance Google spreadsheets. But to actually calculate the true rank, because I didn't realize it gave us the number of houses. So 1, 2, 3, 4, 5. Let's use a spotlight actually. 2, 3, 4, 5, 6, 10, 16, 17, 21, 23, 24, 26, 27. So it's the 27th house. So truly the percentile would then be 27. So we did it for normal, but it would be 27 out of 40. It would be actually 67.5 percentile of all the 40 houses. So that's really how I should have answered part A. So that's my fault. But for part B, that is correct what I did. We found the z-score, and we did the normal CDF and the calculate or norm dist, and you get the percentile there. Okay, sorry for that confusion. All right, any questions about 2.11? Nope. Okay. So look at 2.12, and I think now I'll probably have you guys try it, and then we'll share our results. So we do have normal distribution. You do have the mean. So let's get a highlighter out. You have 12,000 people. You have a mean of this, a standard deviation of this. So how many students ran the mile in less than 6 minutes? So again, you will need to calculate the z-score. There's a question in the chat. No worries, take your time. So for part A, you will need to find the z-score. Remember, to do normal CDF in the calculator, it's second, bars, and you will need to pick option 2. And you will need to do, the second bars, option 2. Remember, your lower will be -1 E99 because you're going less than 6 minutes. Your upper will be 6. Your mu is going to be 7.11, and your sigma is going to be 0.74. Or you could do in Google spreadsheets, and you can do norm dist 6, 7.11, 0.74, and 1 because we're going to the left. You do 0 for going to the right. That's the area to the left of 6. The area to the right of 6. That's his norm dist. And by the way, we didn't really have to find the z-score to do part A. If you do the z-score, then you put your z-score here, and you replace these with 0 and 1. If you did do a z-score. So you don't really have to do a z-score, so I can cross it off. So that's part A. And then part B, approximately how long did it take the slowest 10% of the students to run the mile? We'll talk about it in a second. Go and do part A and share with me what you guys got. Okay. Yes, A, only A. I'm gonna do it right now too. So again, you could do second, bars, option 2. Keep the lower as is, make the upper 6, make the mean 7.11, and the sigma 0.74. Good, great. So we have 6.68%, awesome. So the answer is 6.68% if you do this correctly. So that's how many students ran a mile less than 6 minutes. So that's pretty fast if you could run a sub 6 minute mile. When I was much younger, I think I was able to do it. I think I barely got under 7 when I was much, much younger, or maybe a little over 7. I can't remember. I think it was a little over 7. But yeah, that's really impressive that those can run really fast. You have the right body for it, I suppose. For B. Now for B, what you're going to do, so you have to do the inverse. So you want the bottom 10%. So remember the mean here was 7.11. You want the 10% here. So we really want the lowest times, which is really the fastest people. I mean, that's a good thing, right? Be low here, given the context of this problem. So how do we do this? So we want 10% area. So you're gonna do this inverse norm in the calculator. Remember, you hit second, bars, now you can pick option 3. And the area is gonna be 0.1. We're gonna use our mean of 7.11 and our standard deviation of 0.74. So you do area of 0.1, mean of 7.11, and sigma of 0.74. And actually, let me just pull up here. Second vars, option 3, 0.1, 7.11, 0.74, paste it, so 6.16, which makes sense because running 6 minutes was the bottom 6.68%, so bottom 10% would be a little higher than that. So that makes sense, so about 6.16 minutes. And you can convert that to seconds if you like. Multiply the 0.16 by 60 seconds to figure out how many seconds it takes, but you get the idea. Then part C, suppose that these mile run times are converted from minutes to seconds. Estimate the percentage distance around the mile between 400 and 500 seconds. So again, you're going to do, and by the way, for inverse norm, if you don't have a calculator, just going back to this again, you could, if you like, to do equals inverse norm, or I think you do that one. And if I do 0.1, comma 7.11, comma 0.74, I think if you do comma, only takes 3 arguments, got it. Yeah, there we go. So it gives you that value at that percentile. So you do that as well. Okay, coming back up here again. Here we go. So part C. For part C, what you could do, if you so desire, is you could actually just go to normal CDF again in your calculator, and then you're just going to do your upper as, your lower is going to be 400, upper is going to be 500. And then the mean, you actually need to convert that. The seconds, you're going to multiply that by 60. And like us for the standard deviation. So you also have to multiply it by 60 as well. So we do that really quickly. Tell me what you guys got. So put it in the chat. So again, we're going to do seconds, bars, option 2, 400, 500, 7.11 times 60, 0.74 times 60. And so what percent are we talking about here? What percent of people would run like that? Okay, let's see something in the chat. Yeah, 67.62%. Thank you, Zach, for sharing that. So you get 67.62%. That's what you did. Yeah, go ahead. Okay, good. So something like that, I think I could ask on our test. I think that's good. I mean, I like that problem a lot. Lastly, for 2.13. Okay. You have summary statistics here. And I guess we're recording the amount of oil recovered from 64 wells in an oil field. So remember, N always represents the number of items. Just remember that. N always represents the number of items. We know what mean is. That's just your average. You know what the median is. That's gonna be the middle number. We know these things, right? Standard deviation, that's the measure of spread, how spread your data is. Obviously, that's the lowest. That's the highest. So I'm really dissecting this table here, as you can see. And this is 25th, yikes, 25th percentile. So it means that, oh gosh, I'm covering it, that's smart. This means that 25% of wells have less than 21.4 thousandths of barrels. And that's 75th percentile. Which is that means that 75% of wells have less. Now, you formalize more than, you just do the opposite, and you say, 25% of the wells have more than this. And then you would reverse, say the same thing, then you say 75% of the wells for the Q1 have more. But I'm just gonna keep it as less, have less than 60.75 thousandths of barrels. Okay, so the question here is to, based on the summary system, is the distribution of amount of oil recovered from the well in the field approximately normal? Justify your answer. Okay. I think what I probably would do is let's actually calculate what the 25th and 75th percentile should be. I think that would be a good idea to do. And we do have the mean and the standard deviation there for us. The median is going to be interesting too. We're going to kind of take a look at that in just a little bit. The min and max, I don't think really helps us too much. I don't think I really care too much about the min or max per se. Even though the max might be really high compared to what we're dealing with. But I do kind of care how the mean compares to the median, and I do also care about Q1 and Q3. So what you're going to do is this. We could do inverse norm. And I'm going to type in 0.25 for my area. And I'm going to type in my mean as 48.25. And my standard deviation as, of course, 40.24. And then I'm going to repeat this for an area of 0.75. So let's do it right now. Second vars, inverse norm, area of 0.25, 40.25, 40.24. So I get 21.1 here. So it's pretty close. If I do it again for the 75th percentile, I get a much higher number though. So see, that seems a little off to me. Also, the mean is bigger than the median. So it seems as though the data is being pulled to the right, probably by that max. So actually that max does kind of matter, even though I did say I didn't really care about it. So So my median's here. My mean is here. So it's skewed to the right. So I'd say no. And that'd be one reason. The other reason would be Q3 is much bigger. Or Q3, let me 75th from normal distribution is significantly different. Where's so stuff here? It's getting kind of distracting. Let me write that one more time. Is significantly different than Q3 in the table. So I think those are the reasons I would share for that one. Okay, any questions? Nope. Okay. So I'm gonna have you guys do a little bit of practice in your groups. Just give me 1 second. Let me stop recording this.